Hello, this is Professor Salahat. In this video, I'm going to continue with homework 6. And homework 6 is involving chapter 7. And we're going to start with number 7 here, problem 7, homework 6. And as you see from the problem here, it says, in hypothesis testing, does choosing between the critical value method or the p-value method affect your conclusion? Let me just tell you a little bit about this. Imagine you're at school or work, you want to go home. So there are two ways to go home. At the end of the day, at the end of the road, you're going to get home. You can take the highway, you can take the roads within the city and drive home. Same thing in here with statistics when you test a claim. There are two methods. One method is using the p-value method called. And the p-value method involves this rule, and you always have to remember this rule. If the p-value is greater than alpha, you fail to reject H note. If the p-value is less than or equal to alpha, we reject H note. So this is the rule. Now this is one way to look at it. Usually alpha will be given in the problem, so you don't have to find alpha. Alpha will be automatically given to you. The p-value can be found using StatCrunch, or we can find it using looking back in the tables in the back of the book, but this is not the case. We're not going to look in the back of the book. Now there is another method, and that is called the critical values method. And the critical values method works like this. Usually you will have a problem, and based on HA, you're going to end up with one tail, which is a left tail or right tail, or two tails. Now, let's say that here we have one tail. This is called Z critical. Now, if we have two tails, or I'm sorry, right tail, let's take right tail. This will be called the Z critical. And if we have two tails, it's going to look like this, and you have a Z critical from the left and Z critical from the right. Now, if you are using the Z critical method in all of those three methods here, we have to calculate Z statistic. Now we're going to show you how the Z statistic is going to be calculated. Now, if the Z statistic falls into a rejection region, remember this, if it's a left tail, this is the rejection region. If this is a right tail, this is the rejection region. If it's two tail, there is two rejection regions. So if the Z statistic you calculate depends on the test you're dealing with, falls into a rejection region, automatically we reject H note. Now, we're not going to use the Z statistic method and the Z critical method. We're going to rely heavily on the p-value because it's easier and faster to use. But let me emphasize here, it doesn't matter which method you use. If you use it correctly, it's going to lead you to the same conclusion. So let's go back to our question in here. The question in here, does choosing between the critical value method and the p-value method affect your conclusion? And the answer will be no. Both should give us the same answer. So that'd be a C or D. Notice, let's read C and D and see what they say. C says no because both methods involve comparing the standardized test statistic with the rejection region. That's not true. Both of them will be giving us the probability or the test, again, the test statistic and the p-value both is going to deliver the probability. In this case, we're going to choose D because D talks about no because both, again, the no is for there is no difference. Both involve comparing the test statistic probability with the level of significance. So at the end of the day, if you, whichever method you use, you're going to come up with alpha that will be given and the p-value that will be calculated, and you're going to compare. This is a probability, and that's a probability. And you're going to compare a probability to a probability. So that is the answer to this problem. Next one. Okay, in the next one in here, actually we have kind of three problems in one. And in here we need to remember the rule that I mentioned I started with here. This is the rule I started with, and I need to remember this rule. So in this rule, in this problem here, they tell us that, let me just clear this. They tell me that, and again, we have three levels of significance: 0.01, which is 1%, 0.05, which is 5%, and 0.10, which is 10%. And they gave us a p-value. So we are given in number 8, given a p-value. And the p-value in this case is equal to 0.0722. And we are given three values of alpha. The first alpha we are given is, let me clear more of this. The first alpha we are given is 0.01. The second alpha is 0.05, and the third alpha is 0.10. Notice that the p-value didn't change. The p-value is the same for all. So the p-values here is 0.0722, and here is 0.0722. We were told that if you are supposed to test a claim, and the significance level, by the way, the significance level is the maximum allowable margin or type 1 error. So you're allowed, in the first case, you're allowed to make an error of 1%, type 1 error. Second time, 5%. Third time, 10%. Notice, let's just do this comparison. Notice that the 0.0722 is bigger than the 0.01. Notice the 0.0722 is bigger than 0.005. Notice the 0.0722 is less than 0.10. Based on the rule here that we have on top, okay, for the first two cases, if the p-value is bigger than alpha, for the first two cases in here, those two, the p-value is bigger than alpha. So what do? We fail to reject H note. So in here, in those two cases, we fail to reject H note. But notice in here, the p-value is less than alpha, and here it says if the p-value is less than alpha, you reject H note. So when we come to answer this question in here, the first one, it says, okay, do you reject H note for part A? At the 1% level, we said that at the 1% level, we fail to reject. Let me slide this more. We said that at the 1% level, we fail to reject H note. So we're going to say in here, fail to reject H note can be C or D. Let's read. Fail to reject H note because the p-value is greater than or less than. We know we're going to choose the C because the p-value is greater than the alpha given. And if we check in here, we get the correct answer. Now for part B, they talk about the level of 5%. So for the 5% level here, the 5% is less than 0.0722. So we fail to reject H note. So we're going to say fail to reject H note, which could be A or D. But in this case, we're going to fail to reject because the p-value is greater. So that D is selected because the p-value is greater than the alpha. We check the answer. It's correct. We go to the last part. What about the 10% level of significance? At the 10% level of significance, the p-value is less than alpha, so we're going to reject H note. So we're going to choose reject, which is either B or D. So we're going to reject because the p-value is not greater, because the p-value is less than. So here we answer the three questions for this problem. Now, I'm going to look at number 9. In number 9, they give us a two-tailed test because they said, find the p-value for the indicated hypothesis test with the given standardized test statistic Z. So they gave us a test statistic Z, which is equal to negative 2.15. And they gave us alpha. And they tell us this is a two-tail test. It's a two-tail test. So this is a two-tail. So there are two rejection regions. Okay. So the first thing we need to do is, if the z is given, which is negative 2.15, we can find the p-value from z. Notice that the p-value is a probability. And we learned in the previous chapter that if you give me a probability, I can give you, if you give me a z, I can give you a probability. So give me z, give z, I give back probability. In this case, the probability will be the p-value. How we do that, we said this before, is you're going to go to stat, you're going to go to calculators, you're going to go to normal, and then what you gave this z. Remember, because this is a left tail, you can do it either from the left or right, because there are two values in here. So you gave me a z here, which is negative 2.15. Notice, because of the two tail, there is another z, which is 2.15. But let's focus on one. Let's find the area to the left. So we're going to go to p of x under negative 2.15 equal, and the last box will be the probability that we're trying to find. So if we do that, we're going to get the probability in the left corner. So let's just use StatCrunch in here and show you. We're going to go to stat, we're going to go to calculators, we're going to go down to normal, and we're going to go to, remember, leave the mean and standard deviation 0 and 1 because z is given. And in here we have a negative, let me clear this, we have a negative 2. I forget what the number is, 2.15, sorry. So 2.15, when I hit compute, that's going to give you the p-value in the last box. You see the last box in here? So the p, the probability, it's not the p-value here. The probability is going to be 0.01577, and again, repeating. Notice, because this is a two-tail test, we know that this here area is equal to that. We know that with symmetry, this area also is equal to the same. So if you want to find the total area, is going to be 2 times 0.01577, and you continue, which is, again, here is my calculator. If I just multiply 2 times, again, you can add or multiply 0.01577. Let's stop here. That's going to give me 0.03154. That is the area. Notice then the total area is going to be the p-value. So the p-value, if there is one tail, it's that area only. Let's say this is just a left tail, then the area will be 0.01577. If it's a right tail, it's going to be that area only. But if there is two tail, we have to double the area, because again, the left tail is going to take something and the right tail is going to take something. Okay, so if we put this answer back in, let's see if we're going to get this right. If we put this and this down, we get, oh, it says in here round to 4 decimal places. So I'm going to go in there and I'm just going to put the point. And again, slide this up here. We're going to, let me use the keyboard. That's easier. It's going to be 0.03. And again, I need 2 more digits, 0315, because they want only 4 places. Oops. Now we made a mistake. Let's double check our numbers. Okay. So let's go back to this. And this number is 0.015, 0.01577. So let me multiply that by 2. 0.0157 by 2, 0.0315. That is a correct number. But again, there is always a chance that I am famous with making those mistakes. Okay, native 2.15. Let me repeat my steps again. Stat, calculators, normal. I'm going to go to under native 2.15 and hit compute, and it's going to be this number. Okay, so then multiply that by 2. So it's going to be 2 times 0.0157761, and it's going to be 0.031. Oh, that is my mistake. It's not going to be 15, it's going to be 16. Sorry. Because again, if you look at my calculator in here, if I go 1, 2, 3, 4 places, there is a number 6. So that is my mistake. And if I hit check, it should work. Sorry for that. Again, we made a mistake in here. I put the p-value, which is 5 something. Again, rounding issue. So don't round the answer till you get to the final step. Okay, let's go to the next one. Oh, there is another part to this. Okay, so the question in here is this. We found the p-value, which is 0.0316, and alpha is given in the problem. Look at this. Alpha is given here. Alpha is given in the problem. So alpha is 0.05. We know that the 0.03 is less than 0.05. Alpha, what we do is reject H naught. So we're going to go in there and reject the H naught. So if this is our decision, we're going to reject H naught because the p-value is less than alpha. Okay, so let's go to the next question in here. And the next question is, which is number 10. Number 10 is says, find the critical values for the left tail test. So this is a left tail test. If it's a left tail, this here is called the Z critical. So find the critical value for the left tail Z test. So we need to remember it said Z test because later on we're going to talk about T test. So the T test is different than a Z test. With alpha, remember they gave me alpha. Alpha is given to be here 0.07. Notice alpha is, if there is only one tail, alpha will be the area of that tail. So alpha is the area of the tail. If it's a right tail, then alpha will be the area of the right tail. If there is two tails, the alpha will be split in half. Half will be in the left tail, half will be in the right tail. And notice that alpha is a probability. Okay, and alpha in this case is 7%. So you're allowed to make a type 1 error, but you only are allowed to make, like, the probability of making a type 1 error is only 7% of the time. Okay, so we need to find the critical value. Again, this problem takes a probability. I need to find Z. So the steps that we mention all the time are here: stat, calculators, normal. Notice that it is a left tail, so we're gonna the mean. Point 0.07. So the probability is 0.07. What's the Z critical? So if I follow those steps into StatCrunch, and let's see, here's StatCrunch. I'm going to go through stat, calculators, normal. I'm going to go in here. Notice that I know the probability, which is 0.07, and I do not know what Z is. So when I click in the box in here, That's going to give me the Z. So the Z, when I hit compute, the Z is going to be, which in this case called Z critical, is going to be negative 1.47. And let me avoid the mistake I made before. And let me write everything down before I round. 75, then 791. Let me go back to the problem and see what they want. They want the answer in here to 2 decimal places. So for 2 decimal places, I use, again, don't forget it's native 1 point. And again, only 2, it's going to be 1.48. Now let me stop for a second, because in here it says use a comma to separate answers as needed. Notice that you don't need that. Now we use a comma when we have 2 tails. If we have 2 tails, then we end up with 2 Z criticals, one in the left and one in the right. So when we write them, we write the first one, comma, we write the second one. In this case, we don't have to do that because there's only one critical. So when we check the answer, it is okay. I'm going to stop here with this video, and we'll do another one shortly.